Good morning, everyone, and welcome to Signals and Symptoms podcast. I am extremely grateful today for Edmund White to join us from Germany. He has a very unique perspective, and in all honesty, I'm actually it's above my pay grade what he's going to discuss. So I'm going to let him introduce himself and then talk about AI today or OI tomorrow, which is Organoid Intelligence. And one of his theses, and of course, he has done some major work in it. He's essentially a biomedical innovator and an author, but he's going to tell us about what he thinks of AI today. And then we're going to look into Organoid. And as usual, I'm not a good host, so I'm going to push back between organoid and quantum computing and then discuss all of that and give them hard questions as usual. Again, I'm grateful to my bestie Ed, co-host, and Harvey is in his way. By the way, if you're not following Harvey on his Substacks, please do so. This is a very small read. I love it that he basically, concentrates on one point and then goes from there. A few updates from the week before towards brain MRI foundation models, from clinical findings to the FOMO challenge. And again, these challenges essentially produce a lot of data that you can actually use. Most of them is open source. And then you can actually go ahead. This is very interesting study. Anyone who's interested in looking at how to develop brain MRI foundation models. And we discussed this last time that the way the foundation models in radiology is going to happen is that there's so many findings. Like, so brain scan has a ventricular megaly, intracerebral hemorrhage, you can name it, like if they have devices or not devices, etc. So we're going to pull these into like CT brain model with multiple pathologies, and that's going to have CT abdomen model, and then it's going to roll into a major model which is called CT foundation models, and therefore we're going to have MRI foundation models in the future. So this is how we're stepping forward towards it, and we're going to see major changes coming in behind. And as I said last week as well, we're going to remove a lot of tasks from radiology, but the job of radiology is not going to go away, but tasks are going to go away. Multi-center external validation of clinoradiomics model. And this is again one of those things that we are now able to use. Radiomics is some of the extra data, metadata. Think of a picture that has your geotag, where it was located, something. If you look at Google Photos, you can actually check your metadata on a photo. Think of an MRI's metadata is actually called radiomics. And I can use that metadata now because now I have access to AI and do something about it. Very interesting study. You should look at it. Confirm upstaging biopsy. So very small use case, but very interesting as we go along. Oh, this is the data set, by the way, for this study that we had. And you can actually go ahead and download it if you want to from Hugging Face. Artificial intelligence for antimicrobial resistance. And this is again a review paper, but it's fantastically written, that how you can go ahead and actually use a standardized pragmatic framework that is aligned with the fire line curations, etc., and then use AI to do this. Very interesting read. I think we're going to put it in the show notes and our Substack as well. Hospitals are already using AI. Why implementation will determine its impact. And this is again one of those things. We have talked about it. Ed is amazing about it, and it's basically any tool you introduce. You can, for example, a hammer. You can hammer a nail, or you can hammer a thumb. And hope you don't hammer your own thumb. You actually hammer a nail. So the question really over here is that AI is a tool, and we need to implement it properly. And that's what exactly this determined. Again, it's a okay read, but the point was I wanted to re-emphasize what Ed teaches us all the time. Augmenting structured diagnosis through use of pre-trained large model and clinical notes. What does structured diagnosis mean? There's two things, which is called ICD-10 codes, by the way, which is insane, like why we use it for billing. It is actually World Health Organization International Classification of Disease. But since we are US, we didn't design a proper coding system for billing. But what we did was we reuse ICD-10. But what this does is actually how you can extract it better for real clinical use in terms of diagnosis. Because ICD-10 has its limitations, Sonomat has its limitations. And I think at some point in time, we are going to build a brand new system rather than using these medical oncologies, but come up with a new oncology for the age of AI. I hope so it happens. Technical challenges in autonomous robotic ultrasound examination. Did you see that, Ed? It was insane. You can now have robots doing your ultrasound. Freaking It's just crazy.
It is
Um,
amazing.
and then again, this one goes through it again, how it uses digital twins. It's insane, like where we are in robotics as well. This is my favorite topic because I believe patient-centered outcomes depends on gamification. It's a bias of mine. I think we humans are relied on our pleasure centers and something that has to tick our dosage in the brain to go through this. And of course, we have Apple and we have Google Fitbit Air. By the way, highly recommended. I wish Google was sponsoring this segment, but what I'm saying is that insanely good, and we need to see those visual status gamifications, rewards, and of course social accountability, because my brother is saying, hey Junaid, it's been 3 days and you're sitting in your ass, what aren't you moving? And that is very important. Gamification with social accountability, I believe, is the only way that you can treat health patient really centered outcomes. So very important paper, and how it's going to be incorporated in clinical trials. Again, Harvey is not here, and we are always talking about med tech, which is just semantics I came up with, is talking about medical technology, FDAs, all of this, which is quote unquote a sick care problem. And then, of course, healthcare, which Ed is championing about wellness and all of that, and how they're crossing over and building the new healthcare system. And that's actually what's happening, is how we're using these gamifications to improve, actually moving in acceptance in clinical trial. That's the key term. We are actually seeing these movement into clinical trial and showing it to FDA as a real endpoint for approving some of these things. So very interesting movement in terms of digital technology. Fast, slow, okay. Um, so when you are actually looking at large language models, how do you adopt them or how to create them? You're going to see that those who are actually deep into moving these technology forward, this is a very interesting read. It's more technical than for everyone's case. And then, of course, QSync. Now, of course, everyone knows about AlphaFold. AlphaFold was done by Google. It is very interesting that quantum neural network for multi-dimensional syncing and discovery in protein folding. The reason I'm actually indicating this right now is that we're going to see biologics personalized much faster as we go along in the future, because it will take my DNA, my RNA, my process of protein folding, and may design a medication. Again, we thought it's going to be, honestly, I thought this was just somebody bullshitting, but no, it's not. It's movement is very fast on that regard. So we're going to see some amazing things coming forward. And then this is again qualitative, not quantitative, multi-frame methodology for analyzing health related with patient safety incidents. Again, it's a very important topic of mine. I really think that patient safety issues need to be center, and how do you develop a whole platform around it is a very beautifully written, the graphics and the whole process. So very informational, good read. Again, we'll include it into our system. So coming back to our amazing host Edmund White, I would really, again, very grateful, and I would like you to please forgive me of not doing the right justice on your introduction, but reintroduce yourself and then go from there.
Wow. No, thank you very much, Junaid and Ed, and very honored to be participating in your podcast today. So, and greetings from Romania. I live in Germany, but I'm in transit for some meetings this week in Romania. Yeah, just a little intro. So about myself for people who don't know who I am. So I'm basically been working in sort of medical innovation up to 30 years now, and primarily, really most of my life has been working with technologies that really, when patients are sick and coming in for arrhythmias, heart failure, and helping them to with devices to improve their outcomes. And been doing that for various different guises in large corporate startup companies. And then about a few years ago, started reading and thinking about how can we get prevention more into the equation. So, for example, can we actually stop these patients coming in so late and get earlier on intervene? And I saw one of the other podcasts, someone was talking about prevention, I think Philip Jerwell. and kind of triggered. So this kind of triggered my mind. So about 2024, 23, brain organoids came. I was thinking about brain organoids, and I was looking really about, well, these models have been around actually for many years, but at that time the frontier models started coming in. So you had like OpenAI launched, Anthropic came, and there's a kind of AI was a piece which hadn't really been there with organoids before. So there's a kind of like a nexus, and I was actually working on what we call digital twin technology. So I was working for an organization where we could take 3D echoes, actually, of children's hearts in congenital heart disease, and made them into 3D models. So we could actually look at twinning technology. So all these things were starting floating in my mind, and I thought, and then I started delving deeper into this whole topic about brain organoids, and it was just so many different dimensions coming out of that from a medical point of view. First of all, and there are many other aspects there in terms of personalized, first of personalized medicine, looking into energy efficiencies, for example, and looking into computation and whether models could, we live in a very much a silicon world today. We're dependent on chip technology. Could these be an infrastructure for our future? But always for me, it's always about patients got to come first. Can we build, can we build technologies that help the patient outcome? So this is what kind of got me thinking, researching, and actually eventually to write a book, because I just felt the message really needed to go out there about organoid intelligence there. And organoid intelligence is really the combination of, so brain organoids were developed from induced pluripotent stem cells back over a decade ago. There was a lady called Madeline Lancaster from Cambridge, and she was doing some research into this sort of microencephaly. So patients probably heard about 10 years ago or longer actually, that in South America, there was Zika virus, and a lot of babies were being born with small heads, and she was doing some research into that using organoid models to see how that was development. And then about 2016, John Hopkins University, so Professor Tom Hopkins' group have been really scaling up brain organoids. And it wasn't until about 2023, 22, perhaps we'll come on to this, is that there was some experiments done to really test the input and output of these organoids in a kind of closed loop system to see if you could actually train them. And that's where the kind of organoid intelligence kind of was created. So a group of scientists came together in Baltimore and created this new kind of discipline. And for me, it was fascinating because there was just so many things that will impact our lives out of this, both today and also if we look science fiction, future as well. So that's kind of what was driving me. And I work in the medical space, tech space, but I also have a very strong interest in this brain organoid side as well. So, yeah.
Fascinating. Ed, do you want to go first, or as a neurologist, you want me to comment?
Oh, well, I was going to say yes, I'll go first, but then you added a qualifier
No,
there.
go.
So,
yeah. So
yeah.
I just want to set the stage up, and then I'll let Ed go. So as a neurologist, as you said, organoid is extremely important, and essentially going back to the basics. If you go to cell stem or you go to neuron, but again, of course, that's a little too deep for me. But I mean, one of the things that I have been concentrating on since my birth of my first child, which was actually a premature, and then how much I had to spend time to make sure that the language is important. And you have seen all of these kids that we do, like they're going to say, like for example, yesterday, my 7-year-old said, "I hurted my elbow," hurted, which is a grammatical error. But then I was looking at it on some research, like how many kids do this error. Interestingly, it's only 4% of the time. And then I realized like how LLMs actually learn. And then, of course, one of the biggest problem with Sam Altman always says, well, we are using this much energy to train LLMs, but think about how much energy a human being uses to come to a PhD level. And that was like a very controversial statement. So that's number two. And number three, you're absolutely right that we are living in a commoditization and demonetization of intelligence itself. And then energy demands are actually going significantly up, and we need to figure out a problem to solve over here. So number one, learning itself in terms of human versus machine. And number two big statement is how do we go back to the basics, how humans learn and human stem cells work and protein, and how to optimize our process. Because at the end of the day, I know Claude and ChatGPT are amazing, and unfortunately, I have to compare myself. But my brain uses 20 kilojoule calories as compared to what they are using. So at the end of the day, I have a very efficient system here as compared energy efficient system. So that's number two layer that you properly suggested. And then of course the last one, doesn't matter, or we should just put some more solar farms. So I'm gonna let Ed start with the conversation now. Sorry, I had to put that sort of staging for the episode.
Yeah.
Go ahead, Ed.
No, I thought it was super fascinating. We'll definitely have to put the how to order the book in the show notes.
Absolutely, yeah.
And I misspelled organoid, but I think everyone knows seeing the comments. So this is all a new topic area for me, so I found it really fascinating. And I was wondering, Edmund or Ed, if you could share a little bit more about. I was just looking at some of the notes I took. If you think AI is the future, think again. This is your quote. The next frontier merges biology with tech, building intelligence from living neurons rather than silicon. So that's pretty profound. Can you? I mean, we've touched on this on the periphery a little bit, but can you kind of expand on that? Because again, I know for you two, you guys are like-minded, and you have this a very engineering and medical understanding. But for the bulk of the audience, they may not have that. Can you unpack that a little bit? Because I loved neurons rather than silicon. That's very fascinating.
Yeah. For sure. Yeah, no, for sure. So look, we all want things predictable in the world. Our silicon, our chips, everything we use is all very predictable. And it's been, silicon's been around for over 60 years. And it's in all our devices, we use it day in, day out. And we don't really think about it. We just have it there in the background. So it's very good. I mean, there's nothing wrong with silicon, but one of the big issues is that it's energy. It takes a lot of energy. With the learning language models now, the data warehouses are growing. There's more and more energy requirements. And it's also not just the energy, but it's the water as well involved in cooling these big data centers. So there's a lot of energy demands exponentiating in the world today. And that's one of the drivers. And the second piece is, in biology, biology is not really predictable, it's adaptable. And it's very it's very clever in terms of how it works. It doesn't use a lot of energy, but one of the challenges with biology is that you've got to nurture and grow that cell or whatever. It needs a nutrient system or something there. And there's been work today in building biological computers. So groups like out of Melbourne, Cortical Labs have been developing these biological computers. Mm-hmm. They need nutrients, they need things to support them to grow. And I was thinking, in the world today, that I don't think we could today build an infrastructure around biology and replace it with silicon. That's not going to happen today, but you could take the best elements of those worlds. So the silicon reliability, the kind of consistency of that with the energy of the biology and the adaptability, because it's a very deterministic model in silicon, but the biological one is so adaptable that if you combine those two, a bit like a hybrid car where you got the petrol and the electric, you got that hybrid approach. That architecture could start creeping in more and more into devices, into medical tech, into our lives. So I think that's where things could head. I mean, in the future. So it's very much dependent, but the energy question is always going to drive a lot of this. I think worldwide for ourselves. And if we're using more AI in the hospitals, for example, to do more decision making, and we're outsourcing more of that stuff, the energy requirements of hospitals are going to go up, and that those sustainability arguments, those KPIs that those hospitals have to meet are going to also be under challenge as well in the long term. So it's kind of like different things like that. I think I hope that kind of explains it in a very simple way of where these two sit together, silicon and biology, and how that could pan out.
Yeah, makes
so
sense.
at the very core issue since 1960s or more, we have been basically have transistors, and definition of transistors is zeros and ones, and we are making it into a billion of series. What quantum computing, as we discussed last time, is somewhere between 0 and 1, and therefore there's actually probabilistic computing. By the way, the biggest issue is quantum computing. Quantum computer works today. It's the cooling thing. That's another problem, energy
Yeah.
consumption. But the second problem is how to convert that into zeros and ones so that we can see it on our laptops. So that's been the tricky part for like decade now. We have had quantum computing for some time, and that's really where my next question is, like, how do you use neurons? And neurons may actually have a different quote unquote base layer of architecture, which is different than silicon. And even if you look at, you know, ARM diagrams or x86 that has been going on for years, which is again a zeros and ones infrastructure, but how you use the instruction set for the actual memory layer. How do you think that neurons, and even non just neurons, I mean, we use neurons just because, I mean, retina may be retinal cones, and as a matter of fact, I read a study that, you know, rods and cones may actually be better in terms of 0 and 1 switching or something else. So any human cell would have to overcome that, right? Because let's just be honest. I mean, I would love to have, you know, this last a month on charge, but
Yeah.
I still want to order my freaking DoorDash, you know. So where does that transition plan look like to you, from like the quantum thing that I'm saying? How do you translate a layer of biology into zeros and ones, or do you not need it if we're going to have something completely new?
You're asking about. So I'm not. First of all, I'm not an engineer, so
No, that's okay. But but you read more than I do, because I'm just like
yeah. So I think quantum plays a huge role, and I think it will take off in the kind of the psychology of everybody when we get kind of personalized quantum computing, which I believe Microsoft, don't quote me on that, are have been plans to work on. So I think at the moment the quantum world is very much in the big institutes, the cooling, those big. I saw one a few years ago down in Munich, one of these quantum computers, and it's a heavy piece of kit. But the framework that it is creating with the frontier models and with brain organoids and neurons, I think there's going to be some sort of infrastructure one day or quite soon which can build within that and have some connectivity between that. Because in quantum computing, you can take signals. So the brain signal is so much to decipher signaling wise. You need more than what we have in the frontier models. So quantum system will be able to kind of assess that in a very, very smart way. So I think the convergence, and I have a Substack thing called Intelligence Life, looks at the convergence of AI, quantum, and life science. And I think the convergence of that will happen. We don't know what form it will take, but it has to somehow happen at some point.
I totally agree with you. Yeah, I mean, go ahead. Sorry.
Yeah, no. Sorry, I just.
You're absolutely right, because one of the fascinating things is interesting, and I'm going to put that to my co-host Ed, which, by the way, is my mentor as well. So Ed, here's the thing: we have democratized and demonetized intelligence, and Ed is saying, and rightly so, that it may take 3 years, 5 years. And by the way, as you can see, AI is solving problems that we were thinking not going to be solved. For example, biologics, like just quantum folding problems and stuff. We know that the acceleration, that flywheel, is now active. I mean, the way that the LLMs are release date is so fast, like Gemini 3.5 in 6 months as compared to 1 year. The flywheel is on. Like we are off to the races. And then the humanity of ours, as you keep saying, is way more important than, you know, Junaid's, you know, technical prowess. What do you think we're gonna do when artificial intelligence, which is demonetized and democratized intelligence, that is cheap and does not require that much energy? What are we gonna do as human beings in general? 8 billion people. I'm gonna let Ed and then you answer.
Oh, okay. So this reminds me when I was at Cleveland Clinic, and there was this group of physicians who started BrainX AI. It's a big, world
Mhm.
global think tank. I know
Good
you
friend
know
of
it.
mine too. Yeah.
Yeah. And
Mhm.
so they would invite me every week. We'd meet in the College of Medicine, and it was not too far from my office. So I wanted to show support for all these super smart people. So I would dutifully show up. But the only problem was they thought that I may be as smart as them, and I wasn't, and I'm not. And so they would always like present these amazing, like these mind blowing ideas, like we're talking about here, and then they would turn to me thinking, "Oh, he must be the source of wisdom because he's leading, technology and digital strategy." And I was like, "No, actually, I'm here to learn," and I was always learning from them. Um, but I don't have a profound answer, Junaid, to this. Would really like to hear more from Edmund, but I'm what gets me excited about all of this is that we run into limitations as we're talking about that have extreme environmental impacts, and we have other possibilities now, right? We haven't thought about previously, like OI, that we're main topic, and there's some other ideas that have been flowing in the chat as well from the audience. Other ideas. And so I'm just super excited the fact that yes, with 8 billion people, and we can't, with what we know about quantum computing today, and we would run out of resource. We'd have to build things in space, like Harvey's working on. Um, but that's like taking old ways and putting it in space. That doesn't make sense to me. I get it. Putting data center in space. I mean, it makes
I'm going
sense.
to tell Harvey
However,
about it. I'm just messing
yeah.
with you.
Well, because what all we're doing, and I'll get back to the topic here in a second, but all we're doing is taking today's mindset, like this is the only way we know how to do it. So naturally, it's put it in space. That makes sense. But as Edmund's pointing out, there are other opportunities, and so that's kind of my general reaction to your question.
Love it. At first, address the elephant in the room because I am actually like honestly scared. I mean, just very honest, right? I mean, this is what's going on. I mean, I had to fire 50% of my company, and which really sucks. I mean, I hate it, and as a person to do so. But this is right now, literally coding it out in front. Give me 1 second. I sat down last night and I told them that I need a complete coding done, and this is a whole module being done, and this is three of them are currently running. This is my part. This is the one that I've completed in the last month, and the team has to catch up. So just giving you the real life impact. Like I mean, this is not coming out from my ass. I mean, I'm just saying that I'm living it with the demonetization and democratization of intelligence. And then there is, how when you're in Germany is the highest tax and the highest benefits. We live in US, which is somewhere in the middle, and then of course there are countries that are not taxed. So talk about the social impact of this as well, especially your experience living in Germany. We are Texans, by the way, so we don't like some of the social stuff. I'm just, I'm just kidding. So overall thoughts about it.
Yeah, yeah. No, it's a very good point. I mean, I've been thinking about this more and more actually the last few months about what we're going to do when we can outsource our intelligence to this. So, UBI, so Universal Basic Income, is a kind of idea that's been touted. I think one country's been exploring that. So give everybody a uniform, income, and then let them get on with their creative pursuits and what they want to do, their hobbies and so on. So there's been ideas like that. So time, traditionally we sat at a computer, we've given our time for many years, decades to work. And maybe that might be in 10 years' time, we look back and think, oh, that was a quaint area time. That we don't actually do that. And so there's going to be a kind of new dynamic to the work. But the problem is, at the same time, obviously, in parallel, we've got all these humanoids who are going to be produced and going to do all the tasks and do the production. So I actually have a very controversial view about where things are going, and I don't think many people are going to like this. So I'll explain it for the first time to you guys. I actually think the cost of everything, we would think inflation, everything's going up in price today. Petrol, fuel. In Germany we feel it a lot. I actually think prices of things eventually will go down in price. So things will drop, because the reason is that we're going to be producing robotic systems to produce our infrastructure, our world around us, and that cost won't be so labor intensive, and therefore the costs may eventually drop for everything that we have. So in fact, that there's worries that we think about working, and we need jobs because we need to support the economy and support that and grow that. But eventually, if there's no jobs because AI is taking all the jobs, where does the money come? Well, we get a universal income, but then who's doing all that? It was all robotized, and the costs just come down. So maybe eventually we'll have a complete opposite. Prices will go down to a ceiling or something like that. So I don't know. That is what I think could happen maybe in the next 15 years. But it's happening, as you say, June. It's happening very quickly. We can do different tasks, and we can automate that. There's a lot of organizations out there, native AI, or coming in and doing tasks, with particularly repetitive tasks at the moment, are being replaced. So those tasks which can be done, and in Germany, I think there is we're seeing a big challenge, obviously, in energy. The war is generating the cost of pricing, and the car industry is under attack, for example, from China, and bringing. There's a lot of different things going on, but there's also a lot of jobs in them which are a very kind of standardized routine, which could be quite easily done by AI eventually. So I think you're right. There's going to be a lot of thinking around how we're going to have a different type of society in the future, given what we're seeing playing out. But it's happening in real time now, and we're living in a living experiment with this. So yeah.
My theory is very simple. Sorry, go ahead, Ed. I'm going to say.
No, finish your theory and then I'll jump in.
No, Ed, you go first.
So, well, because I'm gonna go a little bit off topic.
Okay, so let me show you. So the realities of life have been challenged over time. I mean, from fire to tire to horse and buggy to tools, from knife. I mean, tools have changed humanity over time. I mean, you guys come from a higher society, Germany, US, all of that. I already used to wash clothes with hands. We did not have washing machine in Pakistan. And oh my God, the washing machine was like so great invention. It again requires electricity, every new invention. But the point was that we have seen these, and people keep saying that. I think we will find ways to do something. That's number one. Number two, we need to reinvent how we think things. Just as an example, the economy is probably going to shift from physical money to banking notes to stable coins, and what we call, actually Europe is leading more than US in terms of digital currencies. And that's a new reality we're going to live in. So the whole taxation codes and everything can be rethought. I mean, it doesn't have to be things the way we do it. So I think, as you said, Ed, it may not be UBI. It may be something else. Are you courteous? Are you taking care of your elders? That's how you get paid. Do you understand? Like, there are ways to making sure that social impact is there, and therefore people keep saying that AI is going to be the Antichrist looking over and going to go through this, and that's how you're going to be able to get a plane ticket, which still happens in China. But then that's the real question here, right? Is it really not that important? I think it might be important to actually bring those important subjects in line with what we're doing. So that's my thought. Ed, go ahead. My bestie Harvey is here. We're gonna catch you up in a minute. Hey, Ed.
Okay, so yeah, I'll mention this and get your feedback. I'll say Edmund so that people know the difference between the two of us. And then we come back. Like you said, Harvey can catch up. So, and don't tell him what I said about data centers in space. So, so people might say that we are in an AI bubble. So I wanted to get your response, and I'll tell you, like they will say that you and I, Junaid, Harvey, and maybe a lot of our listeners are in the, let's just say 5% that are out there. We make a living, we leverage AI, and we see a lot of things, but how much of it is actually like translating back down? I'm gonna give you a couple points here, and I'm interested in your reaction. So when I talk about like what I'm doing now in healthcare with AI, people say, Ed, that's you. You're doing it because you know all this stuff, but the average person doesn't know what you know and that sort of thing. That's one argument I get. The other one, which I see a lot, is that there's so much hype. So I spent a lot of time with chief executives throughout healthcare, mostly provider, but last evening with a lot of payer executives. And there's a lot of pressure from the boards, and the boards are largely stacked with people that don't know AI, but they read the headlines of the Wall Street Journal or whatever. And so they put a lot of pressure on the C-suite to do AI. And so they do a lot of pilots, and nothing is transforms permanently. There's just some pilots that are done. They see a little bit benefit, like all the stuff Junaid went through in the very beginning, like all these great studies, but it's less than 1%. So are we in a bubble? And if yes, when does that bubble return to normal, and then we see an uptake of actual AI enabled capabilities, or are we not in a bubble and like this is people better, it's going to hit everyone like a tsunami? Just generally your philosophy, because I get this a lot. I'm very interested, given your past experience. You're a great innovator. You've invented many things that have saved people's lives, and now you have these theories. So I would love to hear your perspective.
Sure. Yeah. So I think if we look back about 25 years ago, there was the internet.com. You remember back in the late 90s, so everything was about internet. Having .com was the big thing to do at that time. Amazon came out at that time. Google actually started in the late 90s. I remember using the Google browser search engine when it first came out on the first day, and it was a really nice interface, and it was nice, but didn't realize how that was going to progress. And then there was a bubble and a burst. So around 2000, I think the .com went, a lot of companies went bankrupt, but there were a few which kind of survived and became sort of today. Obviously, Amazon came out of that, and Google, some of the big titans there. And maybe the same thing is happening today, but I think they're slightly different in terms of that I think we're seeing this in the workplace, that we can actually use these tools to be more productive. So we're actually going through a revolution, but there may be in the long term, definitely 100%, but in the short term, there may be a bubble. This is what I'm thinking, because you look at the valuations of Anthropic, they're going to go public with an IPO, $1 trillion IPO. I just saw an article this morning that you can buy property in San Francisco with stock from Anthropic when it comes public. So the value it really is it's frothing at the highest levels. And OpenAI, and it's also raised a significant amount. So much money's been plowed in. The data centers have been built, maybe in space as well, So is this all going to pop, and there's going to be something there? Could likely, but actually the longer term trajectories for sure. I think we're going to have to be working in a new world, new environment. So I would say there's probably maybe a little bit of short term frothiness, and then a bit of a cut, and then long term it will kind of go a bit like the .com.
Yeah.
From that's how I take that. I have a crystal ball. So.
No, I think that's pretty. I tend to agree with that philosophy. Back to you, Junaid.
So Harvey, Ed, of course, is an innovator, and he has actually written something what we call Organoid AI, and towards AI, basically going from silicon to tissue-based computation. And then we have been discussing computation in general, from silicon to neurons or retinal cells, or finally what we call quantum. So just to catch you up. And then one of the key themes is essentially energy usage. And then the question really is at this point, and it's just the overall impact on the environment, just energy, water, space, an ugly, factory in my backyard, all of those combined. That's what we have been discussing. And we're more focused on energy. And since we have been talking about space. I mean, one of the things that came up was that, hey, are we going to use the silicon in space, or you should just wait for retinal and neuron, which is organoid computing or quantum computing. So this is where we are, and then the discussion moved towards social impact when demonetization, and which is already happening. I mean, Chinese models are so cheap. It's freaking insane. I don't know. Have you been using DeepSeek version 4? I mean, oh my
Yeah.
god, the goddamn quality for the price. I mean, I was not able to spend after using 24 hours for a whole week $3 with 2 PhD level just today. So I don't know what's gonna happen next. So just to catch you up, and then here's the question that we want to go through. That Of course, one of the biggest factors is how do you the computational layers for us is transistors, zeros and ones. Quantum computing is coming through this, and then this is going to go. But what do you think in your future, given your purview of very confidential information that you're going to share with us, of course, what's happening in space computing? How do you think this progresses in your mind?
Yeah, so great seeing everybody. Sorry I'm late. I'm in San Francisco. I'm actually in Palo Alto. I'm in Stanford this week at a great AI conference. It's amazing. But to answer your question, here's the way I see it. We're going to be efficient with everything we have, down to, like you guys just gave some examples, but think about all the compute power. The United States has more compute power on our cell phones than most other places. So why not leverage our cell phones? Why not leverage this compute power that I have on this iPhone? I'm not using it all the time, and where we're on a network. Now extrapolate that concept where it's everywhere. NVIDIA has a thing that they're doing an experiment with 100 homes and putting the data centers on their home. And then those data centers now are in people. And then extrapolate that again to now we're talking about space and having a network of computers. And I know Ed's really into that idea. He loves it. And since he's such a big fan of this idea, I know this is a little controversial, but they're talking about in the future putting nuclear reactors to in space to have even more power on top of the solar power that's there. Now, when it comes to the environment, there's a big push here in the United States saying, I don't want that in my backyard. That's going to increase my prices for the data centers. So with the water uses and the power, it does make sense. We need to go somewhere else. Is that space? Is that the moon? Where are we going to go with these data centers? Or are we going to put a virtual space station, call it, with just the data centers there? So, that's next level. Now, to your point, there's a weird inflection point, and there's many laws to it too. If we make it cheaper and cheaper, we're going to use it more and more, and then we actually make it more expensive. But then you can also argue that with time, we use it so much, and it's everywhere, that we're actually at one point, how much do we really need for our daily living? We're personally looking at doing edge computing in outer space. So imagine a data center, now add edge computing, and now add those small language models on the actual data center, and then everybody can be creative out there of how that could particularly help them themselves. So it's quite interesting. I'm excited to be alive at this time in our point. A couple of weeks ago I was in the Amazons, and I thought, oh my God, if I lived here, I don't think I could do it.
So absolutely true. I just want to give you my personal experience. We did move away from foundation models completely. We always had small models, but we moved up to medium from models, Quinn 3.5, 9B. We looked at the architecture, smaller MOE models. Gamma 4 is what Google came out with, and then we are, officially, fine tuning it with 37 billion parameters to 27 billion parameters, and they are so more efficient, as he suggested. And then parts of it, what we call speculative decoding, is a way of moving things along faster. We are doing edge based, so the idea is that you're absolutely right. We are making everything more and more efficient, and that's actually asking me to actually move up the chain, just not serve small models and then go up to medium, and then one day I truly believe that we can have a large language foundation level model on edge as well, depending on how we structure that energy, and everything. I mean, one of the things, I don't know if you looked at Huawei. Huawei was actually one of the ways that they're doing is that the chip is like this, and they're also interconnected. They actually folded the chip on top of each other and then decrease the connections. So we're seeing new architecture. So Moore's law was like, we thought it was a Moore's law. It was broken for decades. Then we hit another ceiling. Now somebody came up with folding, and then we're breaking the Moore's law again. So again, I agree with the second one, with an example that there are many laws, and I don't know what the word law even applies anymore, because it's just one engineer's dream away from going through this. So going back to Ed, and you have a German experience. And by the way, just a reminder, we love Texans, we love data centers. We're building Star. We are building in Sherman, Texas. We are building Texas Instruments. But anyways, Ed, we of course have a different mindset as a society. We are generally more capitalistic. We have more, business oriented. I mean, of course, everyone doesn't like a data center in the backyard, but at the end of the day, they're not opposed to sort of some of these things. But there are societies who step back, and rightly so, and ask the bigger question, that should we hold off with this extensive pace of innovation before society can adopt it? And there are smaller countries who are adopting it much faster, but then of course able to control it at a government level. Singapore, Dubai, I mean, I can give you more example. So what are your thoughts on what Ed was saying, the AI bubble, which is, you're absolutely right, you're going to see a hockey stick, like a .com bubble, but how this adoption can be controlled, or should it be controlled in the first place?
So Ed, does he mean Edmund?
Edmund, yes.
Okay. Policy and regulation, yeah. So being in Germany, we sit under a lot of regulations in many different industries. As you know, in the medical tech industry, we have the MDR. We now have the EU AI Act, as you might be aware, which was meant to be implemented in August, in a few weeks' time, but now it's been delayed a little bit out, so organizations can catch up. So there are kind of mechanisms to use to kind of put this a little bit and keep the moat high. I think, and particularly for companies and who can get and meet those requirements, it brings them a lot of I think validation if they can hit these hurdles in the regulation side. In the brain space, where in the brain organoid space, just going on this topic again, it's a bit of a gray zone, because the regulations haven't really caught up in this area. The FDA and the NHS now can do, so you can do studies, for example, of these models now, and replace the animal model much more. Since April this year, the FDA said they want more models using brain organoids or organoid derived type approaches instead of animal models. So it takes, I think, vision from policies to see, well, where does this actually going to help the population? And I always feel like if we can help get the best patient outcome, done it ethically in a good way, then we should encourage that innovation, that policy. The other question is also about, uncontrolled innovation. What happens, we're seeing this. I give you an example. We really feel it quite strong in Europe, and I work with some colleagues who are based out in Ukraine. The drone technology has evolved massively in the last 10 years. I mean, the iteration of the tech you would never think 10 years ago, talking about war, I don't want to talk warfare, but has evolved so quickly.
It's a fact of life,
Yeah, a lot of that's unregulated, and it's been reiterations and getting out on the front line. And I'm a bit worried in terms of biology and bioweapons and the way we talk about biohybrid, and if we have unchecked regulation, what does it take for an actor in a different market to bring and get advantage by using some of the tech here? So it kind of checks and balances. We've got to get it right. But at the same time, policy's also got to, so it's kind of, I think it's a balancing act. I mean, we love to see innovation, but we need to keep it just checked and tempered and make sure no one's doing anything, incorrectly.
I mean, I can tell you my personal experience. I mean, MDR and EU Act and everything, and I just gave up entering the Euro market. The regulation is so insane that I said, well, it's not worth it, because I mean, you do. I mean, I'm not, being facetious here, but the U.S. market is much bigger. I mean,
Yeah.
as compared to people talk about Middle East market and Singapore and everything. I'm just going to tell you it's 25% of the U.S. market. Which, by the way, if you have two states, California and Texas, it overpowers the rest of the world. Like literally the rest of the two states. I'm not talking about the rest of the America in general. So then as a CEO, I have to make tough decisions generally. I mean, I cannot do all my research everywhere, but you're absolutely right. Ed and Harvey, what are your thoughts about uh, policing AI? That's the term I think I'm going to use. That. Yeah, you go first, Harvey, and then I'm going to go with Ed Marks.
Well, we all know on the policing side, it's a double-edged sword, right? If we police too hard, are we going to police so hard that we stop innovation, or we slow it innovation? Even if you slow it, especially in healthcare, are we going to affect lives? But at the same opposite spin is if you don't and we do things not correctly, then will these models hallucinate and to the point where it's giving advice to a little kid and they kills himself because the AI told him to kill himself, you know? So there's some really serious repercussions. As these foundational models are adding the guardrails more and more, and these certain models are getting stronger, it behooves themselves to be regulated because something like this happens, it's going to hurt the entire industry. So there's a little bit of self-policing there. Simultaneously, these models at the beginning, the hallucination rates were a lot higher, but now we're getting better at how can we make sure that they don't hallucinate. And then the end user, let's just call it physicians, in my particular case, they're looking at it a little bit different and like, well, wait a second. What if I use it just in my specialty, just in my box, and then just these certain repetitive tasks, and it's less likely to harm? So it's quite interesting to see this science evolve. And I call myself Dr. GPT, but in the future, what is it going to be? What's the next model that's like people are going to look back and look at GPT was like, oh, that was so cute that back then that was simple, but like it's really this, So.
Yeah,
So,
I think
and so the word self-policing is very important. And then using the example of Boeing, and then you can comment on the whole picture. Policing the AI, and of course, self-policing the AI.
to Ed or Edmund.
Ed Marks, sorry, Ed.
Oh,
Ed.
well, I was just going to say, again, I hate going to philosophy because I don't think the United States could pull this off, but we're spending so much money in all these individual hospitals and in the payers and for sure in our partners, vendor partners. Everyone's doing their own little experimentation, right? And we're getting limited impact. Imagine if we could tackle this for all the reasons cited and I'm not a big government person, but if you took a fraction of all that money that's being used and all these, like everyone's got a chief AI officer, right? And then they build a team. You see what I'm saying? And then they make investments. And meanwhile, the profit margins are so small for healthcare, and we've got populations that are underserved, all that kind of stuff. And we're pouring all this money, having very little impact. Imagine if we took a fraction of that took that money collectively and then experimented in a safe environment and just accelerated the pace of change. And American healthcare is so slow because all the regulations and all the governance. And for good reason, again, I'm always trying to think balance. Like Harvey brought out some of the points. We don't want these hallucinations. So anyways, I would love to see us somehow figure this one out where we could do some serious R&D and rapid cycle, because otherwise we're going to get beat. As Edmund was pointing out, we're going to get beat by nefarious actors.
Yep. And that's so true. Edmund, you're suddenly the Chancellor of Germany. This is your last question for the day. And then you have to give 3 points to your Chief AI Officer of Germany as a country. What are those 3 points that you're going to tell him that to work on? Again, that's sort of like a framework question, because the defining point is that policies are essentially at the end of the day frameworks, and they need to be applied per institution basis. So what would be the top 3 things in terms of number one, research dollars going into AI versus augmented AI, quantum AI, etc. The second, of course, is the policy that, and then the third one would be pick a topic.
Yeah, yeah. Good question. Yeah, I think it's about prioritization. In this role, you'd have to really look at what are the segments which are going to have the most impact for the dollar. Germany, you pay a lot of tax and there's a lot of public revenue and a lot of money coming into the funds here. And just as a side note, there's a thing called a black book, and you can see every year where the funding has been impacted and what the outcomes have been. And it's not always very good. But you need to look into areas where you're going to have the most innovation, create an environment with that funding that's going to make that kind of ecosystem, I use the word ecosystem, flourish. So whether that's having anchor point institutes around, so startup or other companies can organize in some sort of ecosystem. I think to encourage that is going to be very important. Also to make that's the second point would be to really look at regulations and really have, and I like in America where when you from a medical tech side, you have these sort of fast track breakthrough designations, which are really good. And I think we need to do a lot more to encourage individuals or a system which can encourage innovation to be reiterated and really get out there quickly. It's happening, but it needs more injection in there and to encourage us. So I think those are the kind of things that will get things moving and would be ideal. And I think at the end of the day, it's got to show an impact on the population, and also from a competitive point, in a global market, we've got to build and train that workforce to operate in this new environment in a way where they're going to feel comfortable and have at their hand tools and technologies that can help the society to do better. It's a little bit of a generic answer here, but I think I do think the system needs to be more freer and have a little bit less policing, as we said earlier, but encourage that in that capacity. That's how I would see it. It's needed today, actually. They're not speaking on behalf of anybody, but I do see there's a critical need in Germany at the moment, and to bring less risk aversion into that environment as well.
Actually, beautifully said. As my besties Ed and Harvey always say, Ed says education, Harvey says culture, or they're their two pet peeves. The future chancellor of Germany has said the biggest priority is not just investing in technology, but investing in people to bring in the AI pro workforce of the future. With that, thank you so much for joining us. Very grateful for Edmund to joining. My besties, see you next week. Thanks.
Thank you very
guys.
much. Yeah.
Thank you.